8.2, position, velocity, and acceleration using integration. So we're going to revisit position, velocity, acceleration now that we know antiderivatives. Okay, but as a reminder, for position, we normally thought about it as S of t, although it could be defined with whatever variable they want to define it as. For velocity, we often call it v of t, but to find the velocity given the position, the velocity was the derivative of the position. Okay, now then we got to acceleration. Acceleration was the change in velocity, so it was the derivative of the velocity, which means it could have also be the second derivative of the position. Okay, speed was related to velocity, except speed was always positive because it didn't matter which direction you were going in. So speed was the absolute value of velocity. Okay, now let's go back to displacement. When we did displacement before, we just thought about where did we start, where did we end, and we subtracted the difference. Now that we know antiderivatives, we can think of displacement as the integral of velocity. Since the derivative of position is velocity, the antiderivative of velocity is not position, it's the change in position, which is the displacement. Okay, and if we want the total distance traveled, which is not the same as velocity, we do the integral of the absolute value of v of t dt, and that's going to give the total distance traveled. Displacement just tells you that the net change in the distance. This is actually the total distance that has been traveled. Okay, let's try it and see what we figure out. Okay, so for example, when a particle moving along the x-axis has an acceleration of a of t equals 12t minus 4, the particle's velocity is 18 centimeters per second at t equals 2. The initial position of the particle is 8 centimeters. What is the function s of t, x of t that represents the position of the particle? Okay, let me just see what I'm given real quick. Okay, I know that a of t is 12t minus 4. I'm trying to get to position. I have acceleration. So I can move one step to go from acceleration. To go from velocity to acceleration, I take the derivative. To go from acceleration to velocity, I'm going to do the antiderivative. So I'm going to go up a degree. So if I want v of t, I'm going to take the antiderivative of the acceleration. So that's going to be 12t squared divided by 2 minus 4t, and then I'm going to add a constant. Okay, now did they give me any information? Yes, they told me the particle's velocity is 18 centimeters per second at t equals 2, which means the velocity at t equals 2 is going to equal to 18. So 6 times 2 squared is 6 times 4. 4 times 2 is going to equal to 18. What is that? 24 minus 8 is 16. So C is 2. So let me plug that back in so I can get my particular equation. We have, well, the velocity particular equation is 6t to the second minus 4t plus 2. Okay, now I'm still need to get the position function, which they would like me to define as x of t. Since the derivative of position is velocity, the antiderivative of velocity is position. So I'm going to take the antiderivative of velocity. So 6t to the third divided by 3 is 2t to the third minus 4t squared divided by 2 plus 2t, and then we'll add our constant. Actually, I already used the c. Okay. This is c value is 2. This is a different c value. It doesn't bother me if you use the same c value as long as you keep track of it. I think I'm going to call this c2 though, so that it's clear that this is a different c value. Okay, now do they give me information? They do. They tell me the initial position of the particle is 8 centimeters. That means initially at t equals 0, the particle's position is going to be 8. If I plug in 0, I get 0 minus 0 plus C2, which is going to equal to 8, which means that my actual position function is 2t to the third minus 2t squared plus 2t plus 8. Okay, let's look at example 2. And this is going to be a calculator active problem. Okay, example 2, Johnny drives to school. His velocity is represented by v of t equals sine of 0.3t plus ln of t plus 1 minus 2 at any time t minutes since he left school during the 30-minute drive. Okay, this is Johnny's velocity. He's going to school, which at the beginning his velocity is negative, so he's actually going away from school. I don't know where he went. So he went away from school. Maybe he went to get some coffee, pick up a friend. Now his velocity is positive, so he's going towards school. He's looping. He went backwards again, and now he's going back towards school again. Okay, we're going to set up the expressions and then have our calculator evaluate them. Okay, so the first question is, how far is Johnny from his house after 10 minutes? Okay, given that we only know his velocity, we would like to know his position after 10 seconds. From position to velocity, I take the derivative. From velocity to position, I'm going to take the antiderivative. So first 10 minutes from 0 to 10. I want the integral of v of t dt. Now v of t is this giant equation here. And I don't always want to type it in the calculator. So I'm going to actually graph it and then call that function up. So on my calculator, where it says y1 in the graphing area, I'm going to enter the function. Okay, so I typed it over here. Well, not really. In my calculator, I typed it under the graphing function for y1. Okay, now I want to evaluate this. I'm going to need to use this function multiple times, and I don't have to retype it every single time I want to call it. So instead of doing that, I'm going to take the, I'm going to do the, math 9? I'm going to do math 9 from 0 to 10, and then instead of retyping it, I'm going to call the y1 function. Okay, now I'm going to show you in class what this is, but I'll describe it to you. Actually, no, I'm going to take a picture of it, and then I'll describe it to you. Okay, so over here, I did math 9, and I entered from 0 to 10. I didn't want to have to retype the function, so I went to the menu where it says VARS. It's down here. And I arrowed to the right to where it says yvars, and then I clicked function, and then I picked y1 and I hit enter. So now when it says y1 there, it's calling this function that I typed into y1, and I still put dx. This way I don't have to retype it every single time. And notation-wise, it's fine to write it like this. You don't have to write the whole expression as long as v of t is defined as this equation. Okay, so anyways, what is the answer to this? The answer to this is approximately 3.010. I could round it to 2 or I could trunk it to 1. How far is he? These are miles. Okay, now they're asking how far is he from his house after 15 minutes? So it's going to be a similar problem. Okay, so now I'm going from 0 to 15. I'm still going to call v of t dt equals, and I'm going to enter this again from 0 to 15, and if I use y1, I don't have to retype the function again. Okay, go ahead and try it in your calculator. And it looks like we should get about 3.3974 miles from his house after 15 minutes. Okay, now it's saying if Johnny arrives at school after 30 minutes, how far does he live, I think, from school? But I can't read it. Okay, well, if he started at 0 and he went 30, let's check his displacement. That should tell us how far he is from school. So from 0 to 30, v of t dt, and I'm putting it in my calculator. It gives me 22.8240 miles from school. That's how far he lives from school. And this is the displacement, so it's the change in distance. So the fact that he went away from school and back towards school and he kind of took some detours doesn't matter. The actual distance from school he lives is 22.8. Okay, now D's asking the last thing. The last thing is asking how many miles did he actually drive? He wasn't driving straight towards school the entire time, so this should be a larger number than 22.8240. Okay, so he still drove for 30 minutes, but this time I want the total distance. So I'm going to do the absolute value of v of t. That way they're counting when he went away from school and when he went towards school all together. And I should not put the absolute value on the dt. Hold on. I just want the absolute value of the vt dt. Okay, now when you put it in your calculator, I'm going to put the absolute value outside the y1. Remember, you can get to the absolute value by hitting math and then going to the number menu. It's the first thing on the menu, or you can do second 0 and it lists a catalog of every single thing there, and absolute value happens to be first because it's alphabetical order. Okay, but play with it and make sure you can find the absolute value button. Okay, so I get 28.4970 miles, which is reasonable because he was 22.8 something miles from school, but he didn't go straight to school the whole time, so a little bit of detouring added up to 28 point something miles. Okay, let's try another one. And we're just trying to use our skills to answer different type of questions. This is not a calculator active question. Okay, so particle's velocity is given by that thing. The function x of t represents the position of the particle along the x-axis. Find the position of the particle after 3 seconds if x of 0 is 5. Let's see. There's more than one way to do it. Let's just, since they gave us the velocity, let's start by just taking the antiderivative. See what happens. Um, 4t to the 4th divided by 4 is t to the 4th. Minus 6t to the 3rd divided by 3. Plus t plus a constant. We do need the constant. What do they tell me? They tell me x of 0 equals 5. So we're okay here. So x of 0 is 5. Should equal to 5. And if I plug in 0 here, I get 0 minus 0 plus c. So c equals to 5. So we need that x of t is t to the 4th minus 2t to the 3rd plus t plus 5. Now let's find x of 3. Okay, 3 to the 4th is 81 minus 2 times 27, 54. 3 plus 5. That's going to be 35. Did they give us units? They did not give us units. So x of 3 is 35. Okay, now that's not the only way we could have done this. Remember, we could have also used the initial information and then added on the displacement since then. We used to do that a lot as well in a previous chapter. So remember, we could have also done, okay, if x of 3, I know that x of 0 is 5, so I just need the change from 0 to 3 of v of t, d of t, and I should get the same answer. Let's check and see if we do. X of 0 is 5. From 0 to 3, what's the antiderivative? No, we already did it. It's t to the 4th minus 2t cubed plus t, but I'm going from 0 to 3. Okay, so if I plug in 3, I get 81 minus 2 times minus 54 plus 3, which is actually, and then I subtract 0, which is nothing, and I end up with the exact same numbers, which is also 35. Okay, so there's more than one way to try these. Do whichever method comes to your brain and seems to work. Okay, now let's consider part B. Find the position of the particle after 2 seconds if x of 1 is -2. Okay, well, this is a different scenario, so the constant would change. So I could do it the same way I had done the other problem, or I could try it the second method. Let's just do it the second method to mix it up. I want x of 2. They gave me x of 1. So I just need to know what the change in position was from 1 to 2, and they gave me the velocity. X of 1 is -2. The antiderivative is the same. Okay, and I'm going to evaluate it from 1 to 2. Okay, what is that? That's 16 minus 2 times 8, 16 plus 2 minus 5. Plug in 1, 1 minus 2 plus 1. -2 plus 2 minus 0. So x of 2 is going to equal to 0. Okay, last example. Okay, what's the total distance traveled by a particle during the first 4 seconds if the particle's velocity function is given by v of t equals -1.5 t plus 3? Okay, I want the total distance, which remember is not the same as displacement. I want to include when they're going away from it and when they're coming towards it. So I want the absolute value of the velocity. This was the first 4 seconds. So from 0 to 4, I want the absolute value of the v of t dt. Okay, now if I was using a calculator, my calculator would take care of this for me. However, I'm not using a calculator, so I'm going to have to figure it out myself. And the issue is the absolute value of the v of t. So over here I have the graph of v of t. Okay, now I'm going from 0 to 4. So from 0 until 2, I can see that the displacement is all positive, which is what I want. However, once I get from 2 to 4, the displacement is all negative. I want that to be positive. So I need to evaluate my integral both ways. Now, because I was given the graph, I can tell that it changes at t equals 2. If they didn't tell me that, I would have to calculate it myself. The way I would calculate it is I would need to see when the velocity was equal to 0. So I would say -1.5 t plus 3 equals 0, and that when I solved it, I would get that t equals 2 is when it changes from, it crosses the x-axis. Okay, but anyways, okay, so from 0 to 2, I'm going to evaluate the velocity as is because it's positive and I don't have a problem with that. Okay, now when I go from 2 to 4, I'm going to take the integral of v of t dt, but my answer is going to be negative and I need it to be positive so I can find the distance in that area. So I'm going to do the absolute value of my result because I know that I'm going to get a negative answer there. Okay, let's try it and see what happens. Okay, antiderivative of velocity. So -1.5 t. Who gives this? Let's make this a fraction. -3 over 2t plus 3. Okay, that's better. Okay, so this is going to be -3 over 2 t squared, and then I'm going to divide it by 2 plus 3t from 0 to 2. Let me finish this right now. I don't want to do both at the same time. Okay, so if I plug in 2, -12 divided by 4 is -3, plus 6 minus 0 is nothing. Okay, now I'm ready for the other one. Okay, the other one I'm expecting to get a negative answer, and then I'm going to just absolute value it afterwards. Same integral. negative 3t squared over 4 plus 3t. I'm going to evaluate it from 2 to 4, and then after that I'm going to take the absolute value. Okay, if I plug in 4, negative 48 divided by 4, negative 12. 3 times 4 is 12. Interesting. Okay, minus, let's plug in 2. Already plugged in 2. It's negative 3 plus 6. Okay, negative 3 plus 6 is 3, and then I get, this all turns into negative 3, but I'm going to absolute value it. So 3 plus 3 is 6. So the total distance is 6 units of something. They didn't tell me the units. Okay, let's look back at the graph real quick, because it totally makes sense. Right here, I can tell that the area under the curve is half of 2 times 3. This is clearly 3 units. This is equal, it's just in the negative direction, so this is really 3 plus 3, and I can tell looking at the graph. But normally it's not that obvious, but this is a very reasonable answer.